talk I'm going to give today is Save Our Groundwater, Recharging Features for the Home Gardener and Community. And I am, as Mike said, a Yolo Master Gardener. I also am happily retired now, 2 years. I've had a number of careers that involved water resources and restoration. I'm a retired restoration ecologist, and I worked for the Nature Conservancy National Stewardship Team, environmental consulting for 20 years, and in the last 10 years, the Department of Water Resources, Flood Management Division, and Division of Environmental Services, working on Yolo bypass restoration. And then finally, in the last 4 years, the Department of Fish and Wildlife doing statewide conservation planning. So hopefully what I learned helps in this talk today and helps you with your home garden and thinking. My goal is to show recharge features and how to build a catchment basin in particular. But to do that, I want to talk a bit about groundwater issues and why we should care, an overview of low impact development, what that is and how it can help you, and then dig deeper, unintended, I guess, in the dry well development or creation, and then provide some resources. I'm going to stop after I give the talk, the bit on groundwater, so we can see if there's any questions there, and then we'll move into the next section. I want to acknowledge a lot of people helped me through my career and through time to just answer my foolish questions to help me understand what's going on in our state, and but also to review this presentation, provide input, and they gave me really good stuff. So from the Department of Water Resources, Division of Flood Management, the Department of Fish and Wildlife, I'm not going to read all the names, but please note them. They're excellent people with lots of expertise. Most of them are locally here in the Davis-Sacramento region, if not all of them. The Davis Department of Public Works and Utilities and Operations, University of Davis at Davis, and the Yolo Subbasin Groundwater Agency, and some Davis residents. So groundwater, it's in the name. Literally, it's the water in the pore spaces among the sand and rocks and silt and clay that sits very deeply below us. Aquifers are water that can be extracted, and they're in formations, large formations typically, or basins that fill and can be extracted. And the water in them can be there for thousands of years, important to note. Why should we care? 40% of our typical year ground water supply for irrigation and drinking water comes from the ground statewide. And in drought years, that could be 60%. The climate change predictions, and important not just at the end of the century, but transcending through time, you're going to see more and more of this effect, is we're in an extreme climate pattern. We have droughts, we have floods, we have wildfires naturally, but because of climate change, we expect that extreme to get stronger. So drier droughts, longer droughts, bigger floods when they occur. By the end of the century, that snowpack that we rely on from the Sierra Nevada is expected to shrink by 65%. So groundwater becomes ever more important to us as our supply. Ecologically, groundwater recharges streams, supports plants and wildlife, and we're sinking. I'll tell you about that. The Central Valley groundwater, 2/3 of it has come from groundwater for irrigation during the last 2 decades. The amount that we've extracted from the ground in the past 60 years is equivalent to 3 Lake Meads. Lake Mead is the largest reservoir in the continental US, if not all of North America. And we've pulled out the equivalent of 3 of those in the last 60 years out of the Central Valley. Our groundwater loss as a result is that 64% of the monitoring wells are now below average, and half of the Central Valley wells are critically, or basins, are considered critically overdrafted. And between 2012 and 2016, just that 4-year period, 3,500 more wells went dry, which means that the residents, the residents and businesses are affected. If you're a small business, small farmer, or a resident, your whole community may have dried up, or your home. You're out of luck. So locally, thanks to the Yolo Sub-Basin Groundwater Agency, part of the state system that I'll talk to you about a little later, they have made available all the wells that are in the county that show monitoring data. And they are, you can click on this link. I can provide it later in the chat if you wish, or you could just note it, but it's live and it's for the public. Live, not meaning in real time, but the monitoring is pretty up to date. And so if you look on the right-hand side of the image, you have some examples. The area in southwest county, Yolo County, out by upstream on Puda Creek, in that region, the trend has been from -60 to -100 feet up until about 2005. And then from 2005 to 2020, it's been progressively deepening now to as much as 150 feet. So that's not good news for farmers. I recently heard Craig McNamara talking about his farms going dry, and he's done tremendous work in California and nationwide, even helping to start or founding the Center for Land-Based Learning. His wells are going dry. They're, the wells are 100 feet. What's he going to do now? The drought and pumping has pulled that down to 150 feet. The top image on the right there is 0 to 60 feet deep over time, and since 2005, now it's going as much as -100 feet. So if you're interested, you can look at this map at any time. Our depth in the county is from generally 20 to 80 feet deep, depending on the season, the amount of rain we got that year, the pumping, and the wet, dry periods in the year. And so importantly, from this pumping, we're subsiding. I try to think of analogies all the time, and I thought, okay, well, are we talking about a layered cake that's in the oven that's sinking after the air, the hot gas releases, or are we talking a water bed for those who ever had a water bed? I'm going with the water bed anyhow. Forgive me for that, but if you think of the Central Valley as one gigantic waterbed, maybe 10,000 square miles or more, and we're pumping the water out of that, obviously there's sand and rock and clay in there. As we pump the water out, the ground subsides, and most of that subsidence is from, or a good deal of it is from the clay layers that have water in it for thousands of years. I'm not sure anybody knows how many years. But as that clay is dried up from the water that's in it, it doesn't expand again. And so the ground sinks. And what is happening is the farmers, and I don't say this in pointing the finger at anyone, it's just what's happening. The farmers are pumping more and more water out of the Central Valley, and they changed their crop from annual crops that could be row crops like lettuce and cabbage and so forth to nut crops that can't be fallowed. And so they're pumping year in and year out, regardless of the drought. They have to keep pumping for those crops. That's what they're making money on. That's what they're pumping the water for. And that accounts, regardless of the drought and with the drought, for a lot of why we're subsiding. So Joe Poland, the picture on the right, was a USGS, US Geological Service employee. And he said, you look up at the sky, you can't tell we're subsiding. How do I get this message out to people that we're subsiding? In fact, since 1925 to 1977, when he made this shot, he said, I'm going to put on a telephone pole where it was in 1925, and here's where it is today, almost 30 feet deeper. Well, guess what? We're still sinking. It's an amazing amount of sinking, that 5,000 square miles of the San Joaquin Valley sunk by a foot, in some areas as much as almost 30 feet. And you may not know this, but the North sinks too. We're not sinking as poorly as the Southern Valley, the San Joaquin, but the North has sunk since 1925 to 1977, 4 to 6 feet. And if you look at the numbers below, the first part of this decade, we sank another up to 4 inches in the Davis-Dixon area, up to 10 inches in the Woodland-Zamora area. And then it's increased. The subsidence in the next decade, the last decade, was 2 to 5 inches, 7 to 14 inches. So we're sinking faster. In 1 year, 2021, during the drought, and we're still in the drought, the southern portion of the valley dropped almost a foot, and the northern portion dropped over a half a foot. And the Davis, Woodland, Dixon area dropped 1 to 3 inches. So we're sinking. What's that mean? The effects of land subsidence, year to year, we might not, what do you see? You look around, the sky's still there. It's hard to see it in many areas. But what's going on is you get reduced flow in the channels and the aqueducts, the big water that moves from north to south, Northern California, Southern California, and throughout the valley. It's more expensive because you have to get it over the humps. There's damage to roads and infrastructure, millions of dollars of damage. There's increased energy to pump ever deeper wells, now up to a half a mile deep. And we're not talking one well, we're talking thousands. Uneven harm to poorer residents that can't dig that deep. They don't have the money to do that. Losses to businesses, residents, farms, whole communities have gone away. And loss of wetland habitat that provides value for fish and wildlife in the streams and rivers in the dry seasons. The image on the right, the colored areas, not the blue, but the colored areas, other colored areas, are subsidence areas since just 2015. Up to the deepest red or purple there is up to 7 feet deep since 2015. What that means is if you live in this Madera, Visalia, Tulare, Madera, Fresno County area, and you just moved there and you looked at some old flood maps, you may be in for a surprise because those old maps don't show you as in the flood zone, and now you are. So what can we do about it? Well, in 2014, the state passed the State Groundwater Management Act and said by 2040, we need to get things in sustainability. We're probably, if not the last state, one of the last states to manage our groundwater sensibly. And thank God we have this, this new law, but it's another 17 years before we have to achieve sustainability in these critically overdrafted groundwater basins. And perhaps an unintended consequence of this is that the drillers, the well users, farmers and others, are using as much water as they can, both for their expanded crops, nut crops mostly, grapes also, but to get the allocation they want to have by the year 2040, when the laws are saying, okay, who gets what? And so we're thinking faster. We have 515 defined groundwater basins, and they can hold way more water than our surface reservoirs can, maybe 10 times as much. And some of the innovative things that farmers and others are doing is an example in the Kings River Conservation District, which I had a small role in giving a grant. If you look on the images on the right, they're flooding live crops. How can they do that, you say? Those things can get anaerobic. The ground there is sandy enough that it infiltrates quickly, and thus the crops can withstand the quick flooding. The water gets down, they get free irrigation water, so to speak, by this flooding. The downstream areas, like Firebow communities, don't get flooded by this winter snow melt from the mountains. And so it's a win-win. And other farmers statewide are looking at the same program or process to do on their farms. Get the water in the basins, make the water cheaper to get access to, help fill the basin, protect from flooding when that's an issue, and benefit the crops. So that's one great idea. Another is locally, there is aquifer storage and recovery that the city of Woodland is doing. They have 3 of them, about $5 million each to build, to get excess water and winter water and put it into the ground. And the city of Davis is doing a feasibility study to do the same thing. So now it comes to what we can do, and I'm going to take a break for questions, but the next section is low impact development features and what we can do. So with that, I'm going to open it up for maybe a few questions, Joan, for about 5 minutes. And I guess put the questions in the chat box and Joan will check them.
There is one question. I understand that as the ground subsides, we lose the aquifers. That is to say, the aquifers won't come back, that the clay will not reabsorb the water. Is that true?
Partially true. So the ground, there's 10 times as much water underground accessible to us than there is in surface water. We will still have that. It'll get deeper and deeper until we get our act in order and you know, have a sustainable basins. However, the layers in the aquifer formation include rock, sand, silt, and clay. And sand, if you think about your sandbox when you're a kid, it doesn't collapse. It's pretty robust, and when you have water in it, and when you have water out of it, it's pretty much the same thing. It's just wet and dry. But when you have clay, if you take some clay, just like your clay pottery, and you take all the water out, it gets thinner, and that doesn't thicken up again. So the ground subsides. We'll still have plenty of water to go into our basins. We'll have that when we, get a better budget as far as putting water in, letting it recharge, and taking water out. But what'll be missing is those clay layers that have not dried up, but shrunk down, won't re-expand. That's just the way the behavior of clay works, certain kinds of clay. And there's several layers of clay, depending where you are in the Central Valley. And the deeper we go, the more we'll extract water from those layers and they'll shrink down. The idea with SGMA, State Groundwater Management Act, is to stop going deeper, stop taking away from those clay layers, stop subsiding, and then start putting it back in to get a stable ground and stable water supply. I hope that helped.
There are no other questions.
All right, let's move on. So what is low impact development? Basically, think of your community with roads and pavement, and parking lots, and your own house has drainage systems, stormwater systems to keep your house from getting wet. You don't want that. But before your house was ever there, all that rain went into the ground. And, unless you're on a steep hill, and even then it went into the ground. And what we've done is we've shunted it away from your house and put it into stormwater systems that take all that water in a community, including every house and business and parking and street. And we shunt it off into stormwater systems that send it, in the case of Davis, into the Yolo bypass. In case of many communities, into their local streams. Well, those local streams then get polluted, they get eroded quicker. And then in the summer, when you would want the streams to have water in them, the groundwater isn't there because it hasn't gone into the ground to slowly go back into the streams. So what low impact development means is take it away from these stormwater drains and put it right back onto your property one way or another to subside into the ground right there in a nice way. And what it does is enables that groundwater to fully recharge the streams in the summer when it's dry. It basically is helping to put a gap that development and extraction have formed in the ground, in the hydrologic system. The hydrologic system is full cycle. It's evaporation, rain, groundwater recharge, stream flow, and then back to evaporation. That's what the cycle is in a nutshell. And when you take out the groundwater, because you've shunted it off site, you've sped the water away from its natural cycle. And instead of slowly going back into the streams, it goes away faster. And so you've broken the hydro cycle a bit. And what low impact development does is put it back in the ground. So it restores the groundwater on site. It increases groundwater recharge to streams in summer. It enables plants on your property and in general by stream sides to have evaporation and transpiration that helps in the atmosphere. It provides tree roots water for your on site when it's there, and then it raises the groundwater table so that streamside plants and wildlife can benefit from it. It beautifies. If you do these different types of features, you can really increase the value and beauty of your house. Also provides for wildlife benefits. It reduces the impacts on downstream erosion and pollution to streams. It protects you if you have puddling, flooding issues on your property. You can reshape your topography and do these features to get rid of those puddles on your path. And you can educate your neighbors to help out. It reduces the cost of regions, communities to manage the floodwater by having less of it go to the stormwater system. So these are a number of different types. I'm going to give briefly an overview of what they are, and then I'm going to do a deeper dive, yes, pun intended again, to how to build a dry well. A bioswale is really just a long trench with vegetation and organic matter and drainage materials. The image on the left, it looks pretty technical, right? It has a perforated pipe, it has gravel. That's a French drain concept if you look at the bottom there. But it also has above it, it has infiltrating soil, and then above that it has plants that can withstand flood flows. And what it's doing is just like the images on the right, it simply slows the water and helps it infiltrate on site before it goes into the storm drain. If you have an overflow, the overflow goes into the storm drain. You can build a swale very simply by micro topography, sloping it away from your house and making a sinuous curve, a snake-like curve through your property and making it pretty, like this stone image. Or you can do a number of different things like that. You can make it highly technical, or you could just slope it and put gravel on, and that'll all help slow the water and infiltrate more on site. A bioretention pond is an engineered basin with an inflow and outflow, a drain that if it's too full will go back to the stormwater system, and it's going to hold water a longer period of time than the swale. It's going to collect it, and the vegetation in there therefore needs to be tolerant to both, in our region, both wetland types of water situations, ponding, as well as in our region, drought, because it's going to dry up in the summer most likely. And there's a number of native plants that do that. There's a number of, California Native Plant Society has an online source for what plants can tolerate those situations, and nursery growers can tell you, what can work for that. A constructed wetland like Davis wetland, West Davis Pond, excuse me, is a bigger thing that's going to have water probably year round. It provides wildlife habitat, same concept. It's just holding water for a longer time, and it's going to infiltrate, clean the water on site, clean the pollutants out, filter it out, and the plants that grow there are going to be water tolerant. And then pervious surfaces is something we can all do easily in our properties. In a developed situation, commercial situation, pavement, like you see in the upper right there is pervious types of concrete. And there's pervious blacktop even. The bottom right is our yard, and it has mulch and gravel. And that mulch and gravel provides infiltration. It provides a barrier against the weeds. We make it, I usually recommend 4 to 6 inches deep of mulch. And it also retains moisture longer. So you're not going to need as much irrigation water in the summer. Lesson learned a month ago. Did we get hit or what? This was way more water. I guess the extreme climate pattern hit us. The bark that we had in our yard, this wasn't an intentional experiment. I'm a scientist, but certainly learned from this one. The wood chips on the left there, the darker ones, they all floated away. And in the top right, you see, hopefully you can see, the bark floated away and clogged up our storm drainage. And you see the chips all over that blacktop. That's what it did. The lighter colored, in this case, doesn't necessarily have to be lighter, but the shredded wood did not float away. So if you're thinking of mulching your yard, I highly recommend shredded wood, not floating bark. And we have floating bark under that shredded wood. So if you put the shredded wood on top, you can use both. It's not going to float away. A rain garden is a pretty place to store water for a brief period of time. The plants, it's smaller than those basins that I showed you in the earlier picture. You can create it pretty creatively with good soil that infiltrates well. You make a basin, and then you have an overflow channel or swale that goes to your stormwater system, and the plants that grow there can tolerate water. I really like the far right picture. It has, it's like a terrace of little ponds that are only going to be ponded for probably a day. but it looks really pretty to me, you know, so you can be really creative with these concepts. So I'll take a quick question on those and then dive deep on the dry well.
Your question is, can you recommend a ground cover for dogs?
We had a dog and we had the mulch that we had in our yard and it worked well. I don't know any specifics about what you can and shouldn't have for dogs. So maybe somebody else on this call does have an answer. Joan?
That was your only question.
All right. Well, it remains answerable till the end of this session by anybody else on the call. All right. So rain harvesting. Oh, I guess I didn't finish off. Well, rain harvesting is just what you see. It's rain barrels. These are taking water from your downspouts from your roof and roof gutters, and they put them right into a rain barrel like you see on the right. You could have multiple ones of them, or a cistern like you see on the left. And there's all different sizes, and you can pump from them or you can use gravity outflow from them, and that helps water your yard. I think I calculated for the irrigation we would need in our yard for our summer would be the size of our big living room. And I think, you know, that's a big hold. So we don't have one, but you can use this and people do, and it's kind of a fun thing. So the dry well, this looks very, maybe to some very engineered. Mine is simpler than this, and I'm going to show you two different ways to do it. One with plastic insert, and one with just rocks in a hole. These features that you see in the images are optional in my view. However, depending how you build it, they are not optional. You need to have a system that allows for outflow. If you build it and the capacity wasn't enough for the water you're getting out of your roof in that storm, you need to make sure that it's going to get out somewhere into a storm drain through a swale, or in the top of the right-hand most big well there's a outflow pop-up where the water, excess water, can drain out. In the left side of that right-hand image is an overground outflow from your drain, your downspout from the roof gutter. And the reason for that is if it's too full, it's got to go somewhere, and you don't want to just spray out the joints, the hinges in your downspout. You want it to easily flow out. So they have it over the ground. There's I guess the main point here is there's many ways to do this, and I'll show you how to do it. There's also an image in the middle of the right-hand figure for a debris catchment. So what you need if you're going to build one is you need to have good drainage. And that's typical of most Yolo drainage. I have a fairly clayey soil where I am, and I still can do it. But regardless of how good your drainage is, you want to connect to the stormwater system, because you will have times when you didn't calculate right and there's more flow than, more water coming, volume coming off your roof than the capacity you built. The water table should be low so it has something to drain to. 10 feet or deeper is good. You don't want to interfere with leach fields, and you definitely want to call 811 before you ever dig deep to make sure that the utilities will come out for free and tell you, and this is general in any digging if you didn't know, they'll tell you if there's something there that you need to not dig there for, some utility line. Comply with local ordinances and size it appropriate to the roof that you're draining it from. So here's a warning. This was a poorly draining site, very cemented clay soil, and the capacity was small, basically the size of a garbage can. They're really not capturing much here. And what they ended up doing is digging a trench and sending it directly to the stormwater system. It wasn't going to help. You're going to choose what type of well you want. You want a rock-filled hole, which is what I did, or do you want a plastic insert or a cement insert, that type of thing. You're going to want to find the location that you can put it. At least 10 feet away from the house is recommended, away from the property lines, and where it will slope down, or where you can make a slope or drainage to your existing stormwater system, stormwater drain in your yard. You want your downspout to connect either underground like I did or overground. The benefit of overground is it won't clog. The detriment of overground is you're going to have to build a swale between the downspout and your wherever you put your dry well. You can put a debris catchment in. I didn't. If you do that, you can clean it out, and that stuff won't go into clogging your dry well. But if you put gutter leaf guards on, there's a double benefit, because you're not going to have to climb those darn ladders or get up on the roof as much anymore. And I love that. We have that on our house. There's some really good leaf guard systems. There's some bad ones too. So it's good to do some research. I was going to bring that into this, but I said, no, that's beyond the scope. But you can ask me and I'll tell you what I've learned. The height is either underground or above ground. If you do it underground, you might want to have an escape pipe that goes above the well to allow the excess water to go out. If you put it right on top of the ground, you're going to build it in a way that lets the water flow to your stormwater drain, which is what I did. So handy dandy, the old house has a 6-part how to build it online, and I modified it to add some things that I think are important. They say build it 4 feet deep and wide, at least 10 feet away, 3 feet from the property line, 10 feet away from your house. And what I added is locate it so the overflow will be to your stormwater away from the house. For safety reasons, it's very important, in my opinion, that you dig and fill that hole in the same day, especially if there is any chance of kids or small animals getting caught in that. Even if you cover it, you know, somebody can lift it or dig under it and get caught in there. So ideally, dig it, don't dig it too deep, and fill it and plan ahead and fill it in the same day. I'm just safety oriented. And depending on the soil, you don't want it to collapse on you, so therefore don't dig it too deep. But you might slope it so that it's not as likely to collapse. Slope it away from the bottom of the hole. You also want to dig a trench that's 1 foot wide and 1 foot wide and 6 inches. I'm sorry, 1 foot deep, 6 inches wide, so that you can put your drainage pipe into that. If you have grass, you're going to save the sod, and you're going to put the dirt on a tarp so you can, make your yard look nice again. Second step, you're going to line it with fabric, like weed protection barrier. And you're going to need enough fabric to go over the top. That keeps the soil from going into your hole. The pipe is a 4-inch PVC pipe. Is what they recommend. I recommend perforated 4-inch perforated pipe that has holes in it to drain out. Theirs is solid. They connect to the drain pipe, and then they send it to the well, and make sure that it's sloping down to the well, and that it goes into the plastic tub that they put in the well, like that. They also pop out the holes in that plastic. You can make this, by the way, with some people say you can make it with a garbage pail, like a stainless steel garbage pail, or some very sturdy plastic one. But you pop out the holes, you pop out a 4-inch hole for the PVC pipe to go in. You want to make sure it flows by gravity from your downspout to the hole. And they only fill their hole 6 inches with rock. The rest of that space is all for water to flow out from. And then they fill it with rock around the hole. Then they put a cover on it, and they make sure that they put a cover on it, and they put a emitter on that you see in this image, so that the overflow can pop off to the top of the ground, and they make the level so that they can line it up with the top of the ground. And then they put landscape fabric over the top after they fill it. And whoops, they put sod and soil back on, and they're done. Our system required that I measure, which I recommend anyhow, the size of your roof, 12 foot wide by 30 feet tall for this segment of our roof that drains to the downspout on the right of the house there. And so that's third. And then I said, well, what kind of normal rainstorm are we going to get? About a 1-inch storm is what I figured. Maybe I should have gone with 2 inches, but I went with 1 inch in a typical storm that will drain out before the next storm comes. That was my thinking. And so 0.083 is what 1/12 or 1 inch is. And I multiplied it all out and got 30 cubic feet of volume is what we need. Then I got this very sophisticated scientific apparatus called a water glass. It's a big glass. And I put rocks in it, and I filled it with water. I took the rocks out, measured the water. Lo and behold, very scientific here, it was exactly half. Maybe it was 0.49. It was half. So that means I'm going to need twice as much volume, because the rocks are going to take half of it and the water is going to take the other half. And the way you do that calculation, because it might not be half depending on the rocks you use, is you just divide the 30 cubic feet by whatever proportion you got. And that'll tell you how much bigger, it better be bigger if you did the math right, your capacity has got to be. So then we said, okay, we're going to dig it 3 feet deep. That means 20 square feet of surface area is what the hole is going to be, and then 3 feet deep. We said we'll build it 4 feet by 5 feet, and then 3 feet deep. And I don't have an overflow drain, as you see in this image. I don't have a debris catchment, as you see in this image. I do have, as you don't see in this image, I do have our dry well all the way up to the surface with just mulch over the top, so it can drain right out. But if you sink it, then you're going to want an overflow port to emit it from. So you dig your hole, then you dig your trench. You dig a trench and you put a 4-inch perforated drain tubing in, if you do it my way. If you do it this old house way, you can use a solid pipe, and that'll keep the water from getting the soil wet right by the house. So that's a benefit. But our drainage pipe, this isn't actually our house. I got these images offline. But if you dig your trench away from the house, it's really not going to leave much water near your house. So that's why I did perforated pipe. But either way, you dig a trench and you have it about 1 foot deep and you have it sloping slightly towards the well. That image on the far right should actually be a little more sloping. I did not use a debris basin. I just have my downspout go straight to the pipe underground. And then you importantly have an exit for the water, excess water, and you can have that flow on top of the ground to a drain pipe, as the far left image, or you can have it through this French drain effect again with perforated pipe and gravel, or just good infiltrating dirt in the trench that goes from your dry well to your stormwater drain. So you have an inflow and an outflow to your drain, and you want to capture as much of the flow in the dry well as possible. And that's the middle image there is filled with rock, and then you put weed barrier over it, and then you put, in our case, mulch on top. And the image on the top right is what it looks like. You can't see a thing. And the bottom right is what it looks like when you take a peek at it and say, is it still good? And you lift the barrier and the mulch, and there it is. So with that, in summary, our valley is sinking. Neighbors and communities are doing things about it, and we can too. Some of the resources for groundwater, if you're interested, the DWR, Department of Water Resources, puts out regular updates on the State Groundwater Management Act and what's happening with our groundwater. Really good read. I mean that. It's very interesting. Probably the best book I've read this year is The Dreamt Land. It's an incredibly good book on California's history, farm history, development history, other history, by Mark Arax, former Los Angeles Times reporter. Guess what? It's available at the Yolo County Library by audio and book. The groundwater data map by the Yolo County Subbasin Groundwater Agency. And then all these resources here, I can put in the chat box if you wish, are available for your benefit on how to build these things. And with that, I can take questions.
First question, when I clean the gutters, there is that gritty sandy material that comes off the roof. Does that sink to the bottom, or is there a filter installed before water goes into the drain or tank?
So that's what that debris basin is for. It's literally a box. The pipe goes in, the pipe goes out, and then it goes into the dry well. So you're allowing a pipe in, the water fills that basin, and the debris goes with it, and then the water exits that little box, I should say, and goes into the dry well, and it's all underground. And then it has you have a little cap that you can access that box and pull out that debris. I didn't do that for our yard, but that's what you can do.
Next question, and what slope for the entrance and exit pipes?
So very little. Water flows so well. This old house, which if you type this old house dry well, build dry well, you'll see there's 6-step way to do it. And I believe that I have it in my resources here. They recommend a 1/4 inch or a 1/2 inch drop every 2 feet, I believe it was. If you have the bubble of a 2 foot level, and you look at the air bubble in that level, and you split the difference so that the line on one, instead of being level, so the bubble is on one side of the framing lines that you see in a level. If you stand the bubble so that it splits the difference over one line, that's the slope. But basically, not much slope. Hope that helped.
That's it.
Okay. All right. So did anybody answer the question of what mulch is best for pets?
No.
Darn. I'm not sure that, you know, I mean, in my opinion, the mulch that's easiest to extract poop from, and the mulch that doesn't hurt your hand when you put your hand on it, because you don't get splinters and things like that. That's what I would be thinking of. Beyond that, you know, of course, you're not going to use mulch that might have poison oak embedded in it, or other poisonous, you know, materials. And if you have mulch that's, let's say, eucalyptus, you know, your dog's probably going to smell like or your pet is going to smell like eucalyptus when it comes in the house. That can be a good thing or a bad thing, depending on you. You're on mute.
Can you put some of those internet resources into the chat?
I can. I'm gonna have to exit out of the sharing if that's okay
Sure.
to do that. And
I'm gonna keep reading the comments. We
okay.
have grass right now and the dog tears it up when it's wet.
Mhm.
Great job, Ron. Really interesting backgrounds and explanations. Thank you. Excellent presentation. Very useful information. Thank you very much.
I love that. Thank you.
Yeah, that was
I'm
good.
gonna go to the chat, and wow, there's a lot of people on.
Yeah,
Very cool.
yeah.
I just threw in the chat everything that I threw in the resources. You can cut and paste that.
Yeah, I'll leave the meeting open for a little while so people can do that.
Okay. Any other questions?
No.
How about a question for the audience? What was the hope? Did you get answers for what you were hoping for from this meeting? You don't have to be nice. Maybe in the chat box, was the meeting giving you what you were expecting? And is that going to help you in your own yards
You're getting a
for your own
yes.
purposes?
Yeah, you're getting yes. And thank you so much. I appreciate the dry well idea. Yes, thank you.
Good,
So
good.
helpful. Thank you, Ron. Yeah, it's all good.
All right, you're very welcome. Well, we can end when you want, unless there's any other questions.
Okay, I'm gonna leave the meeting open so people can copy and paste your chat, but I'm just gonna stop the recording and